All right, kiddos, let's go over the warm-up. Which one doesn't belong? Who wants to raise their hand and tell me which one doesn't belong? Isaac.
They all don't belong.
They all don't belong. Okay, well, which one do you want to choose as the first one that doesn't belong?
We'll say the first one.
The first one? Okay, number one, why?
Because 3 and 4, they don't have bottom part going down. You know, like they go 3 ways, not 4 ways.
Okay, so you're saying that because they don't have something coming down the bottom, they're only like horizontal and then vertical from that point. Okay. Jemai?
4 doesn't belong because everything else is going small to large, and 4 is going large to small.
That's right. 4 is going large to small. It's the only one that's going large to small, so that one wouldn't belong because of that reason. Let me give someone else a chance. Who else wants to tell me? Can someone tell me why 2 doesn't belong? Okay, so they're not going horizontal and vertical per se, they're going kind of more diagonal. Is that what you're saying? The number 2 doesn't belong because it's not going vertical and horizontal. Good. And what about number 3? Why wouldn't number 3 belong?
Because everything now is...
Let's hear it from Caitlin.
Because it's bigger than all the other ones.
Because it's bigger than all the other ones? How so?
If you look at the biggest cross, it has 4 blocks on the end instead of all the others where it has a max of 3.
Oh, okay. So this one has 4 on the end, whereas these just have like 3 on the biggest one. Okay. Fair enough. Good. So I think that's a good reason to show why they don't all belong. Let's go ahead and jump into the lesson today. If you want to grab your blue notebooks, I think you're going to open to page 19 or 20. I'll give you guys a minute. Yes, please. So you should be on page 17. Last semester, we described various functions using multiple representations, especially x, y tables, graphs, and equations. In this unit, we will learn about a new family of functions and the type of growth that it models. Okay? So if we take a look at this pattern here, what is happening to it? In the first figure, how many are there? And what am I looking at? Lilybeth, what shape am I looking at? And how many are there in the first figure? There's 1. So in the first figure, there's 1 triangle. Okay. Ashanti's in the second one, how many are there? 3. Good. I have 1, 2, 3 triangles. Beautiful. And Miss Mia in the third one, how many are there? 5. Good. I'm sorry, that's not 3. That's not 4. That's 3. And in the third one, there are 5. So I don't have a picture of the fourth one, but Emmanuel, if I were to do another extension of this pattern, what would the fourth one look like? Well, let's take a look here. We've got between 1 and 3, what's happening? We're adding 2. Good. So plus 2. Between 3 and 5, what's happening? Adding 2. So between 5 and the next one, what do you think it will be? 7. We're going to add 2. Beautiful. If we continue the pattern anyway. So, yes. Good. So today you're going to do a fun little activity to kind of jump into sequences. Your very young and knowledgeable teacher has been busy, very young, been busy creating patterns and sequences they produce. On page 17, you guys will find patterns that your teacher, your very young teacher, has created. Who is she? I don't know. Your task as a team, you're going to analyze the 6 patterns to find. I will wait. You're going to analyze the 6 patterns to find how many items are in the figures provided. Then you're going to extend the pattern. Let's keep our hands to ourselves. All right, you're going to extend the pattern to find out how many items there are in the next 3 figures for each pattern. So I'm going to go ahead and set you guys off on your own to analyze patterns 1 through 6, and then we will reconvene. I think I'm going to have you guys count Mickey Mouses for figure 1 instead of circles. So let's count Mickey Mouses in pattern 1 instead of the circles. Okay? So I will give you guys maybe 5 to 7 minutes. So you're going to count, that's like one thing right there.
54, 162, 496.
So the first one had 2, the second one had 6, the third one had how much? 18? Okay. So then the fourth one would have 54, and then, I'm sorry, 162? Is that what she said? Okay. And the sixth one would have what? 492? 496? Thank you, Selena. 496. Like that. Did you guys get those same numbers?
Yeah.
All right, so walk me through this. What is happening with this pattern?
It's growing
Okay, that's excellent observation, Isaac. How is it growing?
by being doubled.
Multiply by what, George? By 3. So 2 times 3 would give me, I'm going to do a dot for times so that it doesn't look like a plus somehow. So 2 times 3 would give me 6. 6 times 3 would give me 18. 18 times 3 would give me 54. 54 times 3 would give me 162, excuse me. And 162 times 3 would give me 496. Beautiful. So on the next page, we're not going to get there just yet. I'll wait. Yes? Oh, 486. Thank you. So it's not 496, it's 486. Thank you. Good. Awesome. All right, let's take a look at the second pattern. Erica, walk me through the second pattern. Okay, so she's saying it's plus 4, so that would give us 9. Okay. Okay. Yeah. So 17 plus 4 would give me? What is it? 21. Thank you. And then 21 plus 4 would give me? Beautiful. 25. So we can see the pattern is a little bit different. We have being multiplied, and then we have being added by 4. Yes, Isaac. What's that? Thank you for volunteering. I would like to call on someone, and it could be you, but it could be someone else. Okay? All right. Like I said, on the next page, we're going to be taking a look at beyond the 6th part of the pattern. So let's go ahead and, why is this not going? There it is. Pattern number 3. Oh, all right. I think I have, there. Did our patterns look like this, guys?
Yes.
All right, let's take a look at this one. So we already identified what would happen. Okay, the figure 1 here, this is if we counted circles, but we counted Mickey Mouses, so don't freak out that your numbers are different, okay? These are not the right numbers if we counted Mickey Mouses. All right, but these are okay. Pattern 2, we had agreed it was 5, 9, 13, 17, 21, and 25. And we agreed that we were adding 4 to each one. So we're saying plus 4, plus 4, plus 4, plus 4, and plus 4. So let's see. For pattern number 3, Erin, what is happening with pattern number 3? I already have the numbers up here. I just want you to walk me through what's happening.
It's being divided by 2.
Being divided by 2. Good. So we have 80 divided by 2 would give me 40. 40 divided by 2 would give me 20. 20 divided by 2 would give me 10. And if I was to continue the pattern on, I would end up with some very tiny rabbits, right? Those were what we were counting on. That one was bunnies, right? Good. Thank you, Erin. Isaac, walk me through pattern number 4. What's happening here?
It's being shrinking and grown.
Okay, it's being shrinken and then grown. So let's take a look at what's happening here. Can you walk me through the pattern of how you may have predicted the next ones?
Yeah. I didn't get that far. No.
Okay, so what is happening between 8 and 2?
They're apart.
What's the difference between 8 and 2?
6.
Okay, so this is 8 minus 6 would give me 2. And then 2 to 0, what's happening? Minus 2. Okay. And then plus 0 plus 2 would give us a positive 2. And then what's happening between 2 and 8?
Plus 6.
Plus 6. Yep, 2 plus 6 would give me 8. And then 8 to 18? What's happening there?
Like 10? No?
8 plus 10. Good. Well, this doesn't look like a normal pattern. It doesn't look like anything consistent.
Like 2 going down.
Yeah. Can anyone tell me what is happening with this pattern? What, George? Okay, so you subtract first and then you add. Is there a rhyme or reason to this pattern? I'm going to give you guys like a minute to look at it and then tell me if you can find a reason. So you're looking at like the difference between these differences here? Good. So it's like a secondary pattern. Between negative 6 and negative 2, it's plus 4. Between negative 2 and positive 2, it's plus 4. Between positive 2 and positive 6 is plus 4. Between 6 and 10, it's plus 4. So we do have a way that we could count what is happening because it's growing by that number plus 4 more, if you will. So this between negative 6 and negative 2, you're saying negative 6 plus 4 would give me negative 2. Negative 2 plus 4 would give me plus 2. 2 plus 4 would give me 6. So the number that we're adding by is growing by 4 each time. So with that being said, what would the 7th term be? What would I be adding to 18 to get the 7th term? Beautiful. 14. Good. And we'll take a look at that on the next page. I just want to make sure you guys can see that pattern. So let's take a look at number 5. Lauren, walk me through number 5. What's happening? You're subtracting by 6. So I have 25 minus 6 would give me 19. Good. And 19 minus 6 would give me 13. Beautiful. 13 minus 6 would give me 7. 7 minus 6 would give me 1. 1 minus 6 would give me negative 5. Good. So it's a pretty consistent pattern. Rather predictable. Good. And Israel, walk me through number 6. What's happening to number 6? Okay, can you tell me what the difference between 1 and 4 is? 3? Okay. What about, and we're adding 3, right? 1 plus 3 would give me 4. Okay, what about 4 and 9? What's happening between 4 and 9? Plus 5? Good. And what about 9 and 16? Good. Uh, 16 plus 9 would give me 25. Good. And then 25 to 36? Good. Beautiful. So what is the pattern? What's happening here? Is there a consistent pattern? You're adding 2 to what you're adding, right? So 3 plus 2 would give me 5. 5 plus 2 would give me 7. 7 plus 2 would give me 9. And 9 plus 2 would give me 11. Good. So, I mean, if you didn't see it, you could say we were adding an odd number, like we were just adding the odd numbers as they increase in odd numbers only. Good. Excellent. Perfect. I'm going to move on. Okay. So, maybe. This could be on your next quiz. We'll see. Okay, guys, good job. Now, we are going to complete the tables on page 18 and graph the points for these patterns here. Take a look. We're graphing 1, 2, 3, and 5. Okay, not 4 and 6. 1, 2, 3, and 5. And I believe that it's on your graphs, it's specified where to do it so that you have consistent graphs. Lastly, use the pattern to estimate how many tiles are in the 13th figure. So as a class, we'll find equations for each pattern. We probably won't get to that part today. So go ahead and take a few minutes. I want to try and get to the Kahoot. So go ahead and graph these points. Graph the points that we took, and then estimate how many tiles for the 13th figure.